Question 7. A very straightforward question on credits. I'm not sure what to say. This is boilerplate. You should expect this on every single SM exam. Without any further ado, let's get cracking. Part A. Find the x-coordinates of each of the x-intercepts. From the expression for f of x, we could deduce that the x-intercepts are -2 and 4. Part 2. Find the coordinates of the vertex. Now, we know the vertex is always at the midpoint of the two roots. So because of that, we know that the axis of symmetry would be x equals to 1, and the x-coordinate of the vertex is going to be 1. Substitute 1 into f of x. So f of 1 is equal to -3 times -3, so 9. Thus, the coordinates of the vertex are 1 and 9. Part B. Write down the value of h and the value of k. We are asked to complete the square for this. Well, we know the vertex is h, k. So therefore, h is equal to 1, k is equal to 9. Part C. The line y equals to mx plus 4 intersects the graph at x equals -2 and x equals to 2. Interesting. So, if it intersects the graph at x equals to -2, at x equals to -2, f of -2 is equal to 0. So the line has to go through the point -2, 0. Because of that, 0 is equal to -2m plus 4, and m is equal to 2. Part D. By considering the graph of f or otherwise. Okay. Find the range of possible values of p such that. Now, first off, who is this guy? Well, let's see what we get when expanding f of x. Multiplying the two factors, that would give us -x² plus 2x plus 8. Voila! So, this entire equation that you're given is actually f of x is equal to p. P is a constant. Part 1. The equation has two distinct real roots. Okay, y equals to p is a horizontal line. Now we want to take this line and move it up and down. The number of times the line intersects the curve is the number of solutions that the equation has. So, the equation has two distinct real roots. Below here is going to be 2 roots, 2 roots, 2 roots, 2 roots, 2 roots, all the way up to the vertex, right? So as long as p is less than the y coordinates of the vertex, you're good to go. Part 2. Two distinct positive real roots. Okay, now this gets a bit trickier. You take the same line and you do the same motion. Here you have one negative root and one positive root. You have one negative, one positive, one negative, one positive, one negative, one positive, 0 and 1 positive, and then 2 positives. So the smallest value has to be at the y-intercept. So the y-intercept of the graph of f is going to be 8. And therefore, P has to be between 8 and 9 exclusively. This is the end of question 7.